Welcome to The Explainer. Today, we are diving into something that sounds like it's pulled straight from the future. Can we use AI to design and build the very stuff our world is made of? I'm talking about molecules. Can an AI really just dream up a new chemical on demand? Well, let's dig in. So, here's the big question. The promise that gets everyone so excited. Can you literally just type a prompt into a computer, something like, hey, give me a benzene molecule, and have an AI build it for you accurately from nothing? That's the incredible potential we are going to investigate today. For the longest time, if a chemist needed info on a molecule, they had to go on a hunt. They'd search through these huge, meticulously organized databases. But this new generative AI approach, it flips the whole script. Instead of finding what's already known, the idea is to create exactly what you need right when you need it. That's a total game changer. But is it for real? Is it reliable? We're not just going to take the AI's word for it. We're going to follow the evidence from a really fascinating study by the Institute for Future Intelligence. They put this new tech under the microscope to see how it actually stacks up against real-world verified science. So how did they do it? The way they set up the test was honestly brilliantly simple. First, ask the AI to generate a specific molecule. Second, pull up the official verified data for that exact same molecule from a trusted source, like the PubChem database. And third, just put them side by side and see how they compare. Okay, and as we go through this investigation together, there's just one little clue you need to keep an eye on. Whenever you see a molecule with this little spark icon next to it, that's the one made by the AI. That's our suspect. All right, let's open our first case file, a group of molecules called the acenes. Now, this was a perfect place to start the test because you can begin with a really simple one and then add more and more rings, making it more complex. It's the perfect way to see if and where the AI starts to crack under pressure. First up, benzene. Super common, pretty simple molecule. And right out of the gate, the AI actually scores a point. It didn't just get the structure right. Look at how it drew it. That circle in the middle, that's actually a more modern, more accurate way to show what the electrons are doing from a quantum physics perspective. So a surprisingly strong and kind of smart start for our AI chemist. And this wasn't just a lucky guess. The AI kept the winning streak going. It nailed the next two molecules in the family, naphthalene and anthracene. For both of them, all the properties it generated were a perfect match with the real data. At this point, you're probably thinking this AI is unstoppable. But then came tetracene. We just add one more ring, one more step up in complexity, and suddenly our investigation takes a sharp turn. This is where we start to see the first cracks in that perfect facade. So with tetracene, the AI started to get things wrong. Specifically, it messed up on some really complex properties. Things like log P, which has to do with how a molecule dissolves in fats versus water, its density, its melting point. And this isn't random. These are exactly the kinds of properties that are notoriously difficult for even our best conventional models to predict. It seems the AI hit the very same one. And as they pushed it to make even bigger accusenes, the mistakes got way more serious. It wasn't just about getting a number slightly wrong anymore. The AI started to fail at the most basic thing, putting the atoms together with the right bonds. It's like trying to build a brick wall but using the wrong kind of mortar. The whole thing is just fundamentally unsound. Okay, so we've seen that complexity can trip it up. But what about consistency? Let's check out our second case file. You see, it's one thing to get an answer right once. It's a completely different challenge to get it right every single time. And for this test, the researchers used a molecule called hexachlorobenzene. They didn't just ask the AI to make the molecule once, they asked it 7 separate times. And with the AI's memory wiped clean for each attempt, every single try was a fresh start. So the question is, would it give the same correct answer 7 times in a row? And wow, these results really tell the story. That row in italics, that's the real, verified data from the database. And underneath it are the AI's 7 different attempts. Just look at them. Not a single one perfectly matches the real data. And maybe even more telling, they don't even match each other. The AI isn't just wrong, it's inconsistently wrong. It's basically making up a different story every time you ask. So we've looked at the evidence from the acenes, we've looked at the hexachlorobenzene test. What's the final verdict here? Is this AI a reliable chemist or not? Okay, so here's the bottom line. It's a bit of a mixed bag. For simple, common molecules that we already know a ton about, the AI is actually pretty impressive. But its performance clearly gets worse as the molecules get more complex. It's not consistent, and it struggles with those hard-to-predict properties. All of this points to the single most important takeaway. This is a powerful new tool, for sure, but it is not an authority. Human verification isn't just a good idea, it is absolutely essential. And that conclusion lines up perfectly with what the researchers themselves said. They wrote that the AI's results agreed reasonably well. Now, scientists choose their words very carefully. Reasonably well is not a ringing endorsement. It's language that says, hey, this is promising, but also don't trust it blindly. The potential is there, but the perfection just isn't. So in the end, you could say the AI passed the test for the simple stuff, the things we've already got in our textbooks. But the real test, the true frontier, is what happens when we ask it to do something truly groundbreaking. What happens when we ask it to design a molecule that has never existed before? That is the real challenge for our AI chemist. Thanks for joining us on The Explainer.